up with 5 debts for different students. And I'm going to have student number 1, 2, 3, 4, and 5. For sure, I know the middle student has to have a debt of 47 because that's the median. So over here, I'm just going to put a line to calculate the average. And we can have trouble spelling. And so I select the average command, and then I'm just going to highlight these 5 cells. And so as I plug numbers in, it'll start calculating it for me. Now, just for the heck of it, I just started throwing a whole bunch of hundreds, but I might as well put them in order. So maybe these two have to be less than 47, and these two have to be greater than 47. Over here, I might put 10, and then a 20, and then a 100, and then a 500, and I got a ways to go, right? So this could take me a while. Is there a better way I could attack this problem besides just guessing? Because I'm hoping for an average of what?
611.
611, yeah. So what's a better way to attack this? I got kind of a strategy. Guess and check's not bad. I got the 47 in there, right? It's calculating the average on the fly. That's better than doing it by hand. How do you calculate average? What does average mean? What is it?
Add them all together.
Add them all together and then,
divide.
yeah. So the way I usually write that is I say average equals the sum over the count. Okay, what do we know so far? We know what the average is, right? The average is 611, true? And we know what the count is, that's 5. Can I figure out what the sum has to be then? Yeah, if I just multiply that 5 to the other side, the sum will then have to be 611 times that 5. So let's see, 5 times 6 is 30, so 5 times 600 is 3,000. And then 5 times 11 is 55. Did I get that right? The sum has to be 3,055. So all I have to do is start divvying up that 355. So actually, I'm going to do this by hand before I do it on the computer. So I know I have a total amount of debt of 3,055. Right, that's my total debt. And I know one of them has to have a debt of 47. So doing that subtraction means I now have 3,008. Is that right? The rest of them have to share. So all I have to do is give out $3,008 in debt. So I'm going to go back and try that again in my spreadsheet. Okay, so maybe I'll say, hey, let's let that one be 8. Now I have 3,000 to give out. Maybe I'll let this one be 100. How much do I have left now? 2,900, okay. So maybe this one could be 900. Oops, and this one should be 2,000. Hey, I got it. Okay. So the first time I did this, I just did it on paper, the way I was writing it out here, and I took off the 8, and then I took off the 100, then I took off the 900. But there's tons of different ways you could divvy that up, right? Okay. And so what's the moral of the story here? The moral of the story is if you know the average and you know how many, you know the total amount of whatever we're talking about, whether it's debt or savings or people, credit cards. Okay, so that relationship between the average and the sum and the count is important. And that was kind of the moral of that problem right there. Questions about that one now? Does that make a little more sense, that approach there? And that approach could also be used on this sheet right here. If I know the mean is 500, and I know there's 6 people, what's the total amount of debt they have to have? 6 people, $500. Yeah, their total debt has to be 3,000. So when we're creating our data, we're creating a bunch of numbers that have to add up to 3,000. Because that's the only way the average of 6 people will be 500. Okay, let's write that down again to help cement that in. Average is always the sum over the count. In this case, we wanted an average. an average of 500, and we know the count had to be 6. So in order for this to work out, the only possible numerator here is 6 times 500, which is a sum of $3,000 for every one of those columns, if the average is going to stay at 500. Okay. And we did a bunch of guessing and checking, and there's nothing wrong with guessing and checking because the spreadsheet is a great tool for that. But we have a little more power than just guessing and checking because we know average is sum over count. All right. We need to back up a step. And I am curious about question F here. So in the previously written in the worksheet here, the average mean balance of debt for college students was 500, but the median was $136. Okay. So what does this tell us about how those debts are distributed? Does that mean there's more students with less debt? There's more students with greater debt? So I'm just kind of curious what you guys came up with on that right there. So I'm going to let you review whatever you wrote down. If you didn't write anything down, then think about it and write something down right now. Does anybody remember what I like to do when I get a hard question? And I don't know what to do from last term. What's that? Doodle. Yeah, I start drawing stuff. Okay. Anytime somebody gives me numbers, I sometimes draw a number line. So in thinking about this, I'm going to draw a number line. So let's see, what do we do? We have a mean of 500. 0, let's say 500 is here. That's our average. And the median is 136. So let's see, this is about 250. Half of 250 is 125. So right around here is that median of 136. What does the median tell us about the data? What's that? It's the middle. What do you mean? So average is supposed to be the middle too. So I need a little more than that. What does median tell us?
Numbers that were given.
It's what? Say order, and then what did you say?
Middle numbers.
Well, again, we can't just say middle because average means middle too. Right. So it's got something to do with order. Okay, so if the numbers are in order, what does the median tell us about all of the numbers?
It's the most common number.
No, that would be the mode is most common.
The median, you put them in order from smallest to largest.
Yeah.
And middle.
You put them in smallest to largest.
And you find the middle one.
And you find the middle number. Okay. So about how many, let's suppose there's 100 students in our sample. About how many of those students have to be less than or equal to the median? Half of them. Yeah. Yeah. And not strictly less than, but less than or equal to. There'd be a whole bunch right at 36. So one thing I know right now is that 50% of students, sorry. Either I'm pushing a button or I'm getting excited, it's my electromagnetic force is messing this up. So 50% of students have a debt in that range. Where are the other 50%? They're above 136 and above. How far above? Do we know the max here? No. I mean, somebody could have a $10,000 debt. We don't know. So this is the other 50% over here. Not that way. So if you did write something down, think about what you wrote down, see if this picture helps confirm or deny what you wrote down. Did one of the groups on our table fit this situation here? Yeah, which one? Let's see, where'd my spreadsheet go? Did I delete it? Must have closed it accidentally. I think it was group A, no? That's maybe? Yeah. Yeah, group A. It's up again. Zoom out for a sec. Or this one? Nope. This one? Nope. This one? Ah, there we go. Yeah, group A was pretty close. The median was about 140. That's almost 136. And so I can see in between, right? So we're 0, 100, 110, 170, 1,000, 1,620. The median is right in between the 110 and the 170. That's 140. Okay. But because of these big numbers, the median was drug away from that. So although most students are close to the median, when you agree most, 1, 2, 3, 4, they're close to 130, 140. But then we have these couple big ones that are dragging that average up. So I mentioned this the other day. The average is more susceptible to what's happening on the edges of the data. Really big numbers drag the average to the right, really small numbers drag the average to the left. So there's a lot of things we could say about this situation here. One is I could say, well, most of the students probably have a debt of less than 500. Why? Because at least 50% of the data has to be lower than 500. For sure, 50% of the data has to be at or below 136. So that means more than half of the data is less than 500. Another thing I could say is there's got to be a few people that have a debt way bigger than 500. Otherwise, there's no way we could get an average of 500. And there's probably a whole bunch of other things you can come up with to say about this situation. Here's the bottom line, though. Just knowing the median and the average, that only gives you little bits of information about what's really going on. Even if you know the mode, too. That only gives you a little bit of information. The only way to know the whole picture is to have all of the numbers. And sometimes that's just not doable because maybe there's a lot of numbers. Like think about the US government does a census. Does anybody, I talked about census last quarter. Does anybody remember what it means to do a census? It's every 10 years, okay. And so what has to happen every 10 years? Yeah, figure out the population. How do you figure out the population? You talk to every single person in the United States or their representative, like a parent. Right? Think about that. How many people live in the US right now? 300 something million. That's a lot of people to get a hold of and say, hey, how you doing? I got some questions for you. That's a lot of people. So we summarize it because we can't deal with all of it. Okay, so hopefully you guys should feel pretty good about everything in the worksheet right now. We got our spreadsheet done. We answered some of those tough questions. All right. So before we jump into the 2.9 homework, I have some sample data I want you to look at and see what kind of conclusions you can draw just by looking at my summary. Okay, so I made up a whole bunch of student debt. Okay, so I have a column for debt, and I told Excel to calculate the mean for me, the median, the mode, the sum, right, add them all up, and to count how many students I have. So I have 50 students. Those 50 students have an average debt of 800. What's 50 times 800? 40,000, right? That's my sum here, right? So there's that relationship. Mean is sum divided by count. The average is the sum divided by count. So just based on those 5 numbers right there, I want you to tell me 2 things about the data, how it might be distributed. Based on knowing the mean, the median, the mode, the sum, and the count. Make a couple of statements saying, I think the data, kind of like question F we just talked about. What did I do with question F to kind of figure it out? A little sketch on number line. You can start there. Or maybe just an idea will hit you. Is the mean bigger than the median? Is the mean smaller than the median? What might that tell us? Does the mode play any big role? Come up with a couple of ideas. Write them down.
We're just writing where here.
Just write them on a piece of paper. You write them on the worksheet or even the book. What conclusions can you draw just knowing those numbers, those summary statistics? So there's one statement I could make based on the median. At least half the people have a debt of no more than 700. I could go the other way too. I could say at least half the people have a debt of no less than 700. Because the median splits the group.
So if we were looking at the mode, it would be the most frequently.
Mode is most
Occurring.
frequently occurring, yeah, so more people had a debt of $100 than any other number. Do I know how many had a debt of 100? No, I don't know how many. Were there some close runners up? Maybe, right, to having that many.
Could
Yeah.
be like none of the other people had the same number. There's
Yeah, it could be there were two 100s,
Two 100s.
and every other debt is different. Or it could be there's 10 100s, you know, and there were 10 people, and there were maybe 9 people with 1,500. You know, I don't know. So that's the problem. So just knowing a few summary statistics, yeah, I know a few things, right? What does it mean that the mean is bigger than the median? There's got to be at least a couple people with a debt way above 800 to drag the mean away from the median. So there's some debt to the right that's pulling that away. So that's another statement I could make there. Because of that, I could say, you know, less than half of the people have a debt above 800. Anybody come up with something I haven't mentioned yet in terms of a comment based on summary statistics? So there are a lot of things we can say, but there's also a lot of things I can't say. So would it help if I showed you all 50 numbers? How many people look at a list of 50 numbers and say, oh yeah, I get it? Or you look at it and go, man, that's a lot of numbers. I look at it and go, man, that's a lot of numbers, right? So often what we do is we try to make a chart. So I made a chart to go with this. So I'll show you the chart and you can see what you think about that. Zoom out a touch to see the whole thing. Okay, so here's my chart right here. So I'm gonna, let's see if I can copy that in my notebook so I can draw on it. New page. Okay. So let's see, what was the mean again, the average? That was 800, right? So let's see, there's 500, there's 1,000, 800 is probably right about here. And then 700 was the median, right? So that's right next to it, so right about here maybe. That's the median, 700. So half of the people are in part of this stack and in the other one, oops, 50%. And then the other 50% are over here. And so we can see here, there's a few people with a lot of debt that are dragging that average away from the middle. If we say middle is median. But most of the people are kind of hanging around that average median area. Every data set is different. It doesn't make sense for people to look at the entire data set. So usually what we do is we do a summary. This kind of chart right here is called a histogram. And it's pretty easy to make in Google Sheets. I'll show I'm making this quick just for fun, and then we'll move on. So to make a histogram, Excel is harder to do this in. So I know you use Excel, Robert. I don't know if anyone else here does, but it's a little harder. In Sheets, all I do is highlight my data, all 50 or whatever people, and I say, make me a chart. And sometimes Google will say, hey, you want a histogram? This time it didn't say that. So I just go over here and I switch from line. And if I point to it, it'll tell me what it is to histogram. And Google will try to, and all a histogram does is group things. Okay, it says, okay, let's look at the first 0 to 600, then the next 600 to 1200, 1200 to 1800, and so on. And you can adjust the groupings too. So I'm not going to go over that here. I could do this a lot more in Math 105. But computers make charts easy. It's just a matter of trying to figure out which chart is the right one. Okay. So, but the bottom line is the only thing that gives a full picture is the data, and sometimes it's just too hard to look at the data. So the best we can do is summarize it with numbers like this and charts, either line graphs or other charts. All right, so I think I'm ready to move on to homework questions. Does anybody want to ask a question about a particular problem in the homework? Number 4, F. Okay, yeah, this is a good one. I should get a better view of this.
That the one on the bottom I asked you.
Yeah, so yeah, okay.
There's no good way of figuring this out or something.
Let's see. I'm going to zoom out for a second. All right. I'm just trying to get a version of this I can get a snapshot of to see better. New page. Okay. All right, so what are we supposed to do here again? Which of the following statements are correct? So my recollection is these are just kind of general statements. The data here is just something to look at to help figure it out. All right, so the median is the middle of the data set. Yeah, it's a middle of the data. That's one way to talk about middle. Half of the data points are either less than or equal to the median. Yeah, that one's definitely true. Okay, so, and one of the important parts, you can't say half of the data is less than, it's got to be less than or equal to, because the median could be there as one of those numbers. So the or equal to is important. So I'm pretty sure that one's right. The median is the middle of the data set. Yeah, you're okay so far. Half of the data points are always less than the median, and half are always greater. Well, no, because it could be a whole bunch, like in this situation, there are a whole bunch of 20s in the middle. So some of those 20s were to the right of the median, some were to the left, right? So this one isn't always true. That's sometimes not true. The median is not the middle of the data. Well, it is a measure of the middle, so that one's out right away. The median is the middle of the data set. Yeah, at least half of the data points are always equal to the median. Sometimes none of the data points are actually the median, right? Because if there's an even number, you average the middle ones. So that one's definitely out. So it's got to be, yours will be in a different order when you look at it, right? It shuffles them for each person. But it's the one with the either less than or equal to. That's a key feature of the median. Yeah, and that came up when we were talking about it yesterday also. There was a couple of questions in the worksheet related to that. All right, good one. Other homework questions? The last two, I definitely have those written down. Okay. I have a note about question number 6. So let's see why I wrote down I had a question about number 6. Oh yeah, this is similar to F. So based on knowing median and mean of these two different schools, we try to answer some questions. So most of these are not true. So I'll let you guys try that since nobody asked, and we can always come back to it tomorrow. Number 5. So number 5, consider the statement worldwide there are more than $2.5 trillion in credit card transactions annually. It's a lot. What is the daily average dollar amount? So we want to take that number, divide by 365. So let me do that. 2500. Okay, so I'm gonna have to start adding zeros. So 123 gives me million. 123 gives me billion. 123 gives me trillion. I think I got that right. Divide that by 365, and I get this number here. So let me copy that into my sheet so I can throw commas on it.
This is round.
Okay.
Yeah, then that should be 7 million, but it's wrong. Right.
All right, so hang on, let me throw some commas in here and catch up to you. So 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma. Okay, so that is 600 billion. Okay, how did they tell me around?
A million, so there's 600.
To the nearest 100 million? Oops, where'd it go?
6 billion.
I lost it. Oh, there it is. Round to the nearest 100 million. Okay, so I want to round to that spot, right? That spot right there. So I would say it would be 6,800,000,000 to round that. So that's the answer they want in the first part. How many dollars in credit card transaction are made on any particular day?
It's impossible.
Impossible to know. Who knows? What if it said on average, how many credit card transactions, how many dollars in credit card transactions are made? Then we could say it would be that second option there. But it doesn't say on average, it just says on a particular day, how many, what was the amount? We don't know. Could be bigger than that, could be less than that, probably not that. Yeah, impossible. Okay, that was exciting.
Where's the zero? How many zeros? I wasn't sure about the rounding parts.
1, 2, so 6, 7, 8 zeros. So often what I do is I put the commas in there and then I take them out after. And a lot of the problems will accept it with commas in there. So let me test this one. I think you could probably go 6, 800, comma, 000, comma, 000.
You don't have to give copies.
Yeah, so it should take it with or without the commas. I think all numerical answers are probably like that. Yeah, it'll take it either way. Yeah, so put the commas in. If it doesn't like it, try it out. All right, number 7. Oh yeah, this is an interesting one. So let's just do a couple of them. A, the median of 25 numbers is 13. 12 of the numbers must be greater than 13. Maybe or true. Dennis says no. Not, it could be true, but maybe not. Yeah, this one depends. So this would be might be false. Depends on the number set. Let's do E.
You just said it could be true and it could be false.
Yeah, it could be true, it could be false. So here my answers are either must be true
Oh, okay.
or might be false. Yeah, so we're playing with logic here a little bit. We're playing with words. Yeah. E, the average of 42 numbers is 20. Average of 42 numbers is 20. So the sum of all 42 numbers is 840. Which 42 times 20? On a good day it is 840. Yeah, so this one would be, yeah, it's got to be true. Must be true. Yeah, so you just want to try each one of these and either it might be false, might be true, or it's definitely got to be true. So I'll tell you in advance, only 2 of them are always true. Okay. Number 8, I had a question about. Draw it out, that might help. That's not that bad. Number 9. 9 is definitely one I want to go over with you all, so I'm going to copy that. And then we'll get to the last few. Screen clipping. Control X. Oops, I missed. New page. Hopefully, Daisy's still with me out there. Looks like it. All right. So what do we got here? 5 exams. And the course requires 75% on average to pass. She's got 1, 2, 3, 4 exams so far. What is the minimum score she can get on the 5th exam to pass? Okay, so she wants her average to be 75, right? Because that's passing. So that's the minimum passing grade. Calculate the average, we have to add them up. So 60, and 72, and 80, and 70, and I don't know. We'll call that X. So add them up, divide by 5, and I hope the answer is 75. Another way to think about it, what does the sum of all their test scores have to be here? 75 times 5. 75 times 5.
375.
375. So all of her tests together have to add up to 375. That's 60 and the 72 and the 80 and the 70 and whatever that new grade is. Oops. That new unknown grade is. Yeah. So if I just take away her current grades from that, whatever's left has to be what she's got to get. Right, so take these guys away from that, and we should be all right. So let's see, what is that? 60 and 70 is 130, 282. And if we do that subtraction, 93. She's got to get a 93 on the next test to end up with 75.
How would you do it? Added.
So,
Divided
yeah, so we just added her current test scores up. Her current test scores come out to 282. So then we have to say, okay, what's 375 minus 282? That's where we get the 93. So her next score had better be a 93 or higher, or she's not going to end up with 75.
How would you get 373?
375?
Yeah.
The sum is always the average times the count. If all of her tests were 75, she'd be great, right? So that would mean she has to have a total number of points of 375. Total points there. Okay. So 11 and 12 are about weighted averages. So let's take a look at this first one. Screenshots. And I'll go back here. All right. All right, so there's a couple of different ways to attack this problem. So in a psychology class, 47 students have an average score of 93. And 21 more students take the test and they get an average score of 63.7. And so what we want to do is if we take all 47 and 21 students and throw them together, what's their new average? Now just think about the 47 for a minute. Those 47 students. Some of them got below 93, some of them got above 93, but on average the score was 93. Remember we talked about average means it's the amount everybody gets to share to get the same total. So the total number of points, the total number of points from those 47 people has to be 47 times 93.4. What's the total number of points? How do I figure out the total number of points the other group ended up with? Same idea, right? I'm just going to take the 21 times their average. So if I take the other people, their total number of points is going to have to be 21 times 63.7. What does it mean to calculate average again? Don't you take the total number and divide by how many? Yeah. So at this point right here, to get the average of the whole group, I just add up all of their total points there. And I divide by how many? How many students are there now? Well, the count is now 47 and 21. So this is going to give me the total, or what's another word for total? Starts with an S?
Sum.
Sum over the count. And this kind of thing is called a weighted average. I'm weighting the 93 by the 47 people that got that. I'm weighting the 63.7 by the 21 people who got that average. So that's how to calculate this weighted average. So I'm going to whip that out of the calculator, see if we agree on the number. Let's see, should I write those down? Maybe I did here. Okay. Ooh. And each of us is going to get a slightly different set of numbers on this one. So, pull this over to the side here. I've got 47, 93.4, and 21 times 63.7. And then you divide that by 47 and 21. I get an average of 84.2-ish. Anyone else get that? So when I did that, I can do it all in one shot by taking each of those multiplications in the sum and putting that in parentheses. And then I divide by parentheses 47 plus 1. So if you want to play with a calculator, you can do something like this in one shot. And that's, again, what's called a weighted average. So there's another weighted average in the next one, number 12, and that's GPA. Let's take a quick look at that, and we're out of time for fun.
148.7.
You got what?
148.7.
Something must have gone wrong in your division there. That's too high. It's got to be somewhere between the 93 and the 63. More toward the 93 because more people had that score. That makes sense?
Yeah.
Yeah, so somewhere in your typing it in.
So, did you do it again?
So what I did is on my calculator, I typed this almost like you see it. I put a parenthesis first. And then I typed 47 times 93.4, and then I added the 21 times 63.7. Then I closed the parenthesis. Then I hit my division key, and then I put a parenthesis around the 47 plus 21. There's nothing wrong with doing it in stages and writing them down, but it's kind of cool when you can do it in one shot. So that's how I had to type it into my calculator. I could type this into a spreadsheet also with an equal sign, and that would work out fine. All right, so I'm just going to outline this quick, and we can look at it again tomorrow if we need to. So the way a weighted average works is so a 3.5, that would be, what, a B plus, I think? If you had plus and minus systems. A 3.0 would be exactly a B, a 4.0 would be an A plus or an A, depending on the system. But the more credits the course is worth, that means that 3.5 is a bigger deal. Right? If you get an A in a 1 credit course, that's not as powerful as getting an A in a 5 credit course. So that's the idea of weights. So to do a weighted average here, each of these 5 credits is worth 3.5. Okay? So the 3.5 counts 5 times. And that 2.5, How many times does it get to count? 3 times. Okay. And that 3.0, let's run color, it gets to count how many times? 5. And that next 3.0, it gets to count 5 times also. So each grade point that we got here counts based on the number of credits that it's worth. So that's the weighting part. Underneath, I just have to add up the number of credits. 5 plus 3 plus 5 plus 5. So that's the idea of a weighted average. So give that a shot in the homework. If you have any trouble with it, we can go over this one again tomorrow. Unfortunately, we don't have time for fun with math. I'll have printouts for 210 for you all tomorrow. If you're done with 2.9, I will gladly take it from you. Yep, hand it in, the sooner the better. And don't forget, if you haven't submitted your spreadsheet, submit your spreadsheet online.